Hello class. In this video I'm going to do a kind of a simple run through um, throughout the three different kinds of observational empirical studies that you can do. Now the first one's just going to be a sample study, and it's saying it's a study that looks at a sample, gets the statistic from that sample in order to say something about the population. So this is kind of what we've been talking about recently. So let's say that we're interested in figuring out what the math ability is of the entire U.S. population. Our way to try and empirically get an estimate of what that math ability is of the entire U.S. population would be to select a sample of that population or a subset, and maybe we can measure math ability according to how well they would score on the math part of their SAT. All right, so let's say in this sample, we have a sample of, we'll say, 50 adults, and their average score on the math part of the SAT was a 536. So now that we have this sample statistic, we then use that to estimate what the math ability of the U.S. population as a whole is. So just to kind of give you guys a little bit of the jargon, this number right here is called the statistic, all right, and then we use that to estimate the population parameter. So we actually measure the sample statistic and then use that to estimate the population parameter. And we can do the same for different populations. So we could look at the population of Bhutan. In our sample of Bhutanese people, they had an average score of 544. So we use that to estimate the average ability for the entire Bhutan population. We could also do the same with Bulgaria. All right, and with them we get a different estimate of what their math ability is. And so in going in this way, we can see that it at least numerically speaking, Bhutan seems to have the highest mathematical intelligence or ability. U.S. Second most, and Bulgaria least. Now, obviously, there's other things you need to take into account, like is a difference of 8 big enough to allow us to say with confidence that Bhutan truly does have an overall higher math ability when you look at their population as a whole. All right, is 544 enough more than 536 is for us to consider that to be significant? Because I'll tell you one thing, if what we got for Bhutan was a math ability score of 537, then that's definitely less clear. You know, that could be a difference that's simply due to chance. Okay, so that's when we're working with a sample study. Another type of an empirical study, the observational study. So up until the early part of the 20th century in the United States and in Europe, it was very common for students who went to school to learn Latin, and the reason being that Latin was thought to potentially improve the intellect of the students. It was thought that that Latin was a lot more logical and rational language than English was. So if you could teach your students to think in Latin, then that would improve their thinking abilities as a whole. After all, if you've ever noticed in English, for some reason we park on our driveways and drive on our parkways. If you've ever driven down Pioneer Parkway, you know what I'm talking about. Okay, so I'll also say, before you guys start telling me this is false, that this was a huge controversy in the early part of the 20th century. One of the big psychologists at the time, Thorndike, thought that this was all posh. He thought that studying Latin makes you better at Latin, studying math makes you better at math, studying English makes you better at English, but none of those have any real effect on each other. So we could do an observational study, though, to try and figure out which camp is correct. Does Latin improve your intellectual ability as a whole, or does it just improve your ability to speak Latin? So we could, using the observational study method, all right, we could get a bunch of students, measure their Latin fluency, possibly give them a Latin test, and also give each of those students a math test. Because if Latin is improving their intellectual ability, then arguably it should also be improving their math ability, because that's one part of your intellectual repertoire. So, for each student in our observational study, we record a math score and a Latin fluency score. All right, so here's what we got. By now, you guys are familiar with these scatter plots. When we're looking at this, there seems to be a positive relationship between Latin fluency and math ability. Those that are more fluent in Latin tend to have greater math ability. If we were to measure the correlation, it's going to be positive in this scenario. So it's going to be greater than 0, but remember, it's going to have to be less than 1. No correlation score can be greater than 1 or less than -1. Okay, so the one camp then says, aha, look, we told you, Latin does improve your intellectual ability. Those that practice Latin the most had improved mathematical ability. Not so fast. This is no different than when we talk about how shark attacks are at their peak whenever people are buying ice cream. Buying ice cream the most. That's when shark attacks are at their peak. So just as it's not clear that the ice cream sales has any causal relation to the shark attacks, it's actually going to be the same thing with mathematical ability and Latin fluency. We don't know if there's any causal relationship between the two. It could be that there is what's called a spurious or a lurking or a lurking or a confounding variable. So, for example, your most studious students are probably going to have the highest Latin fluency and also have the greatest math ability. So perhaps the studying of Latin has nothing to do with the high achieving math students also being good at Latin. It's just that those students tend to study all of their subjects really well, and whereas your students who are at the low end on both, they might be your more distracted students or your students that don't really like school, so they tend to perform poorly on both math ability and their Latin fluency. All right, so possible confounding variable studiousness. And the thing is, okay, so I didn't study studiousness in here. I didn't record studiousness. So that's a possible confounding or lurking variable. Whenever you do an observational study, there's essentially an infinite number of possible lurking or confounding variables that I did not take into account that could explain any correlational relationship between these two variables. One of them is studiousness. There could be any number of other possible lurking and confounding variables. So that's why when you use an observational study and you get a correlation, you can never really know what's going on causally. At least you can't know for sure. Okay, so let's look at the last of empirical research method, and that's going to be the experimental study, and that is going to allow us to get more at causality. All right, so we're still looking at this potential for studying Latin to improve your math ability. How are we going to find out if doing that actually helps? Well, let's get a good subject group. All right, so let's get some innocent kindergartners. Now, the first hallmark of an experimental study is random assignment of our participants, random assignment into at least one of two different groups. Let me say that again. There's got to be at least two groups. You could have three, you could have four, and each of your participants needs to be randomly assigned into one of those groups. All right, and so what are our groups going to be here? Well, we're arguing that Latin has some special ability to improve intellect. So that's obviously going to be one of our classes. And the other one, we got to have some kind of control group. All right, so we'll make it French. Okay, so what's the scenario? It looks like when we got these kindergartners, they haven't really started taking a foreign language yet. We start flipping a coin for each kindergartner to see which language they will study, we'll say, for the next 8 years. So about half of them are going to be randomly assigned to study French for the next 8 years. The other half will be randomly assigned to study Latin for the next 8 years. All right. Now we need this control group. I have it as French. It could be English. It could just be no foreign language class, whatever. But you need to have some kind of control group that will give you a baseline for us to compare our Latin group to. We say that Latin improves your mathematical ability. Okay, improves it relative to what? So that's ultimately what we're going to find out. We're going to give both our French students and our Latin students at the end of these 8 years that's that math test. And if the Latin students do better on that math test, then it will seem that Latin actually had something to do with it. If they don't do any better, then we'll know that the whole thing was that the hypothesis was incorrect. All right, now it is important that we try and keep things consistent. So why did we do the random assignment to start with? So that we're not going to have all the studious people taking Latin and all the less studious people taking French. We want about equal amounts in both classes. Latin will have some studious people, and so will French. Latin will have some non-studious people, and so will French. In order to make it a real true experiment, we'd also want these classes to be designed pretty much the same way. If you could have them taught by the same teacher, that would be even better. The teacher doing the exact same foreign language program for both classes so that everything is the same except for which language they're learning, whether it's Latin or French. If you make that the only difference, then if this group happens to be better, then we're pretty confident that the reason that this group is better is because they took Latin. Okay, so the hallmarks of an experiment, I just said one was random assignment, and then the other is that you have to have a control group whose performance on the dependent variable, our dependent variable is going to be their score on the math test. All right. We have to have a control group to get a baseline measure on that dependent variable to which we can compare our experimental group. And that's it for this.